Hi, my name is Anita Merritt, and I'm the collections manager here at Headwaters Science Center. I thought today we'd talk a little bit about carnivorous plants. We have this display of them here. And I thought I would do it as kind of a question-answer thing. I would just field some of the questions that we hear a lot of and give some answers for them, and then talk about some of the different plants that we have. And the first and obvious thing is, what is a carnivorous plant? It's just what the name says it is. It's a plant that eats animals. But it is more than just eat them. It attracts them, it traps them, and it digests them. And then it derives its nutrients from the animals that it's eating. Why would a plant want to do that? That's a lot of trouble for a plant. The reason that some plants have become carnivorous is because of where they grow and the circumstances under which they live. Most carnivorous plants live in extremely nutrient-poor soils. They have no access to nitrogen and phosphorus and things that other plants can derive from the soil. They have very poor root systems. So instead of getting it from the soil, they can get it from the prey that they eat. And that allows them to photosynthesize better, and at that point they then can grow better. So in a way, they're carnivorous in order to be photosynthetic, although they are photosynthetic without carnivory. Some plants are what they call semi-carnivorous. They do some of those things, but not all of them. Maybe they trap an animal and wait for the animal to die and decay, and then take the nutrients from the decayed animal, but they don't actually digest it themselves. That's known as semi-carnivory. So another question that comes up then is, are they dangerous to people? Can they eat people? Simple answer, no. Number one, they aren't big enough. And number two, the digestive enzymes are not strong enough to digest a big animal. The largest carnivorous plant would be probably one of the tropical pitcher plants. It grows as a vine and could grow up to 60 feet long. It can have traps up to about a foot. But that's not big enough to harm a person. They can, at that size, eat small animals, such as maybe little frogs or amphibians, baby bird once in a blue moon, something that falls into the trap like that. But most of them cannot even do that. They eat small land and aquatic invertebrates, depending on where they grow. So where do they grow? They grow all over the world except on Antarctica. Some are specific to very limited places on Earth. Some grow in numerous places. There are a lot of different carnivorous plants. They grow in at least 9 different families, in about 19 genera, and there's over 600 species known. So there's a lot of them in the world, but they're not as common as many other plants because they grow in very specialized areas. If you have tropical plants, they will grow year-round. If you have temperate plants, they will grow in the summer and spring and fall, but they need a winter resting period. And as you'll notice on some of ours, there's a lot of dead plant matter on it, but there's a lot of young ones growing up too. That's because it's just now coming out of its winter hibernation, and it has died back some during the winter. We'll trim all of that off pretty soon, and it will grow back up again for its summer and spring growth.
So question from Jim.
Yeah, that's all right.
Can they use their traps over and over and over again?
Some of them can use their traps many times, some of them cannot. It depends on the plant. The Venus flytrap can maybe close and open its trap 3 to 5 times before it kills it, which is a good reason why, if you have them, don't play with the traps. You're just going to kill your plant. On the other hand, a pitcher plant just sits there and it collects things, and it can live for quite a long time collecting various little invertebrates before it gets full of enough stuff to start to rot. By then it's growing new leaves anyway. Most carnivorous plants in the world are on an endangered list. And the reason for that is because of their limited habitat destruction, and over-collecting for the commercial trade. Just about every plant we have has been bought from a nursery that breeds their own plants for retail trade. If you're going to get them, don't take them from the wild. In some places, it's a felony. The Venus flytrap is native only to a section about 60 miles long between North and South Carolina on the coast. And in North Carolina, it's actually a felony to steal a Venus flytrap. So know your laws before you go taking plants in the wild. How do they catch their prey? That's another good question. They obviously can't go running after it, so they have to attract the prey to them. And most of them will do this with a nectar, the same as a flower attracts a bee or something for pollinating. Bees have nectar around the edges of their traps. See if I can show you here. Like around the top edge, this is a pretty good leaf, you can still see it, would be nectars that would attract them. Once they get on that ledge, it's a very slick, slippery surface on the inside, and they start to slide. All the little hairs in there are all pointing down, so as they slip, they can't crawl back up again. All they can do is fall further down the trap. Inside that trap is water and digestive juices just sitting there waiting for them to fall into it. When they do fall into it, it starts working on them. And pretty soon it's eaten its prey, and the skeleton of the invertebrate stays in there because there's no way for it to get out.
Inside there, it's not like animal hairs. What are they?
No, they're little plant hairs.
But they kind of look like animal hairs.
They would look a lot like animal hair, just that they all point down and they're slick. So when you're trying to crawl back up, it'd be like trying to crawl through a bunch of spikes sticking down, which is another reason they can't eat people. Not only is it not big enough, but we're stronger than all of their defenses to keep us in there. We'd just walk out if they were big enough in the first place, which they're not. There's a number of different traps that these plants will use. They're either active traps or they're passive traps. An active trap, like the name says, is one that actively moves to catch the animal. A passive trap just sits there and waits for the animal to trap itself, which they do nicely. Another common question is, how can they get pollinated if they eat the insects? Which is a very good question when you think about it. One of the strategies that they have is that most of the flowers are on a long stem, so that the carnivorous part is way down here and the flowering part is way up here. Most of your carnivorous plants don't specialize in flying insects. They specialize in crawling insects. So you have that separation. Another one that they would sometimes use is some of your carnivorous plants are only carnivorous at certain times in the year. During their flowering period, they're not carnivorous. Another one, you have your carnivorous plants are either terrestrial, they grow on the ground or in trees or something like that, or they're aquatic, they grow in fresh water. I have never heard of a marine variety. But in your aquatic ones, the plant is underwater, it flowers above the water. So again, it's a physical separation between the carnivorous part and the flowering part. Any other questions you can think of? Any questions from the audience?
So one that I had personally that I was just thinking about here is they are using their leaves as their traps. So how does them using their leaves as traps affect how well they're able to absorb sunlight? Are they giving something up there?
Yes, there is a trade-off. It's a balance that the plant has to achieve on its own. It can photosynthesize anywhere it's green. And as you can see, there's green pieces on the plants, and they can photosynthesize. In order to exist totally on photosynthesis, they need certain minerals and things from the ground that they can't get. So they take part of their photosynthesizing tissue and turn it into a trap, which then reduces the amount of photosynthesis that leaf can produce, but it gives it a trap that can catch the nutrients that it needs in order to photosynthesize. So it's a trade-off.
Yeah, so they probably, I was just thinking about this, I'm the one who collected the stuff you're seeing in the tank.
Yeah.
And I'm thinking about it, like where we found the pitcher plants was an area that didn't have like any top cover at all. Like it was big and empty, and the pitcher plants are pretty much the tallest things in the area.
Right.
So they're probably getting an excess of sun, so they could trade off like that.
Well, most of your carnivorous plants like a lot of sun, and that's one of the reasons. One of the plants, can you see that okay? This is a Venus flytrap. It's one of the best known of the carnivorous plants. We do have one here at the Science Center, but it's just waking up from the winter and isn't very photogenic right now, so I'm using a picture. But you can see how its leaves, they're red. So its trade-off is more dramatic than, say, the pitcher plant, which has green leaves still.
And the red doesn't photosynthesize as well as the green does.
Right, the green is where the chlorophyll is. So this has a more dramatic trade-off between the two.
If you put a carnivorous plant in like some really nutrient-rich soil, can it get by without being carnivorous?
No, you will burn it up and it will die. It cannot handle it. It has specialized in its area to the extent that it is unable to exist in others. That's one reason why they tend to be rare in places, because they can't grow just anywhere. I thought we'd talk a little bit about the Venus flytrap because it is so well known. This is what the trap itself looks like. And you can notice on it that it has two lobes. That is the actual leaf. The little green thing there is the petiole, which is kind of like the stem that leads to the leaf. Now it can photosynthesize, it's green, but this cannot so well. You'll notice also it has little black trigger hairs. It attracts an ant or something. Probably 30% of its diet is ants, and another 30% is spiders. Maybe 10% of grasshoppers, a few beetles, very few insects that fly. Some, but not so many. But it attracts its animal, which then gets on the leaf. As it hits those trigger hairs as it walks around, if it hits them a couple of times, the leaf will close. The edge of the leaf will not seal tight. If the insect can crawl out, it gets free. At that point, it was so small that it was not going to do the plant enough good to trade off for the amount of energy it would need to digest it in the first place. If it can't get through and it struggles to get out and it hits those trigger hairs some more, then it seals down tight. And that's when it then releases its digestive juices and starts to digest the animal. It can take up to 2 weeks to digest. If the animal had gone free, it might take it a day or so to open again, but it would wait for another one.
And so are the leaves red because that attracts?
Partially, yes. The same as flowers have cups that can move quite rapidly under certain circumstances. But the Venus flytrap and the plant known as the water wheel are the two active traps that move fast. This is a picture of the water wheel. It is a remnant of times gone by. It's the only one in its genus still left alive on Earth today. There are records of about 19 other species that used to exist, but this is the only extant one. And you can see on the top here, the two lobes. It's quite similar and related to the Venus flytrap. And it works in the same way, except that this is aquatic. So something swims by, it hits the trigger hairs, and it snaps shut, the same as the Venus flytrap did. It just does it underwater. Let's see what else I had there. Okay, this is another one we don't have here at the Science Center. This is known as a bladder wart. It is native to this area. In fact, bladder warts are found all over the place. You can find this in Lake Bemidji. You can see its little tiny bladders. They're all over it. What it does is it makes these little bladders, and then it sucks out the air and the water and creates a vacuum inside the bladder. It has a trap door on the opening. I don't know if you can kind of see where the opening is right at the end of them. It's kind of hard to see, but they're there. And it has little trigger hairs on it. So some poor unsuspecting little creature swims by and hits those trigger hairs. It springs the trap door, and the vacuum sucks in the water and whatever is in the water and slams the door shut. So it's got its meal.
So it's a lot like a mask I just moved too, where it just opens its mouth real big and everything in front of it flies right in.
Exactly. And then it pumps out the excess water and it pumps in the digestive juices and it proceeds to eat. Those are your most active traps. There are some others that are somewhat active, but not overly. One of which would be a sundew. This is a common sundew that you might find around here. It has kind of a spoon-shaped leaf, kind of a rounded leaf. What I'm going to show you is this one, which happens to be a tropical one, but it's a linear leaf, but you can see it better. And it's the real deal. You can see on it the little tiny hairs. On the tip of each hair is this glob of glue-like stuff, kind of a mucus type thing. And a little bug crawls up there and gets stuck in it. And he starts to struggle trying to get loose again. The entire leaf can curl up around it, help to secure it, and digest. It excretes digestive juices, and it eats its dinner. When it's finished, it uncurls and lets it go. But these are cute little plants. They're quite common in different plant stores. Sometimes hardware stores will have them. Usually what you get is the linear because it's tropical and it lives year-round. The ones that are not tropical go down for the winter, which is what's wrong with ours right now. They're down from the winter still. Another one that is sort of active is your Butterwort. You can see on it, this one in particular has little curled edges on the leaf. And if you look where the animals might be, there's little dimples in the leaf. If you look close, you can maybe see that. That's the extent of its activeness. It is a flat leaf plant. If you don't look at the sundew that's growing in the middle of it here, this is a butterwort. They're just little plants, but they have sticky glue-like stuff on the surface of their leaf. And an animal gets stuck on it and starts to struggle, and the plant secretes more, and it secretes digestive enzymes. It may curl up the edge of its leaf to keep those enzymes and stuff from rolling off the leaf, and it creates that little dimple and fills it with digestive juices, and the animal kind of sits in it. It doesn't cover the animal, and it doesn't physically trap the animal with hairs or anything like that. It just traps it with the stickiness. So it's passive, but it's mildly active.
So this sticky stuff that some of these are producing, do other plants make something like that and they're just kind of repurposing something that other plants have, or is that something that's unique to these carnivorous
No,
plants?
there are other plants that do this also. A number of your semi-carnivorous plants will do it. They will trap an animal, but they don't digest it. They just wait for it to decay on its own, and then they extract the nutrients from the decayed animal.
I guess what I'm asking is this like the sap of this plant? Like,
No, it's secreted specifically on the leaf.
okay,
If you were to break the stem, it would not be inside the stem.
okay.
Then we're going to talk about the pitcher plants. There are a number of different kinds of pitcher plants. Your two main ones would be your American pitcher plant, which is native to North America only, and your tropical pitcher plant, which is native to a number of different tropic families. These are your old world pitcher plants. This is your new world pitcher plant. They both work on the same principle. They grow a pitcher from their leaves. You can see on this one in particular, it's very easy to see where the leaf border has fused together to form the pitcher. A lot of these will have an overhang, and what that does is help to keep the rainwater from flooding the whole thing out and washing all the enzymes away. Some do not have that, and they are subject to overflow. Some of the ones subject to overflow will have a little hole at a certain point, which allows the excess water to drain, just like your bathroom sink has a drain on it.
So the water that's in them isn't rainwater,
It can either be rainwater or they can put the water there themselves. Your tropical pitcher plants, they form a pitcher also, and it works on the same principles, but it grows from a tendril off the midrib of the leaf. So this is actually the leaf. This is an extension of the midrib, which then forms a pitcher at the end of it. So same strategy as far as catching anything, different strategy as into how they make their pitchers. Do you have any other questions? Anything you can think of that people might be interested in?
You're doing pretty good.
You're welcome to stop by the Science Center and see our live plants. In the next couple of months, they will start to look a whole lot better because they'll start their spring growth. And most of our plants go down for the winter, but they're coming up now.
Thanks for watching, everybody. We will be live again at 3:30 tomorrow. It's probably going to be James doing something, I think, tomorrow. So we will see you then. If you want to come see us in person, we are open Friday, Saturday, Sunday, Monday right now. So Friday, Saturday, and Monday, we're open 9:30 to 5:30. Sunday, we're open 1 to 5:30. So come and visit us in person. Come and see these plants. Come and see